Yes, ma'am.
Okay. So today we will move on to the next part, that is the second module, where we'll be studying about the various data structures, nonlinear data structures, right? And the first data structure that we are going to start with, that is related to the binary search tree. So can I with the binary tree that you have studied in the last class in the course of data structures? So in that we study that binary tree is a tree which has two child nodes, right? Right. So, and when see in that order, so the data that we are putting, that is just placed in the tree in the order that we have received. So if it is received in some random order, so we are just putting the data in that order and creating the complete binary tree. But when we say we are talking about the binary search tree, it has a property that all the data is arranged in some order. The order is that the parent node, the node that is the left child node, will have the value which is less than the parent node, and the right child node will have the value which is greater than the parent node. So this property has to be maintained in the binary search tree. Now for when we are maintaining after creating this data structure, we have certain operations that can be performed over this binary search tree. And this tree, that and you can say this binary search tree, this property we need to maintain throughout whenever we do any kind of operation. See, in the search we don't have to maintain any properties, because while searching, only thing is it makes it easy. If we have to find the minimum value, we know, because all the values, because on the left subtree is going to have the minimum value. So that means whenever we have to find some minimum value, we need to search on the left side of the binary search tree. And whenever we have to find out the maximum value in the binary search tree, we need to search on the right hand side. And for the insert operation, see, when we are doing the insert operations, at that particular point of time, we have to see that this property of the binary search tree, that must be maintained, that the in the two segments, that the left subtree must have the value smaller than the parent node, and the right subtree must have the values which are greater than the parent node. And if we want to traverse, we have different traversal methods that you have already studied for traversing through the binary search tree, like pre-order traversal, in-order traversal, and post-order traversal. But see, what is the, can anybody tell me what are the, when we do the insertion, deletion, or, what are the, what is the worst time complexity of the binary search tree for any operation? Anyone?
ON.
ON. Now, what can we do? See, what is the problem that do we have as some method with the help of which we can improve this property? Like as we have been discussing in the classes, that the in the binary search tree, when we are searching, the what is the you can say we are doing any kind of operations, like when we are searching, it is the order of OH, right? The time complexity of the binary search tree is of the order of OH, where H is of the order of log of n, right? Because why it is of the order of log of n? Because at every point we say the data is, the search is divided into half. Because if we are searching for some operation, searching for some element, we start from the root node. So either we will be going left or we will be going right. We will not be traversing. We will not be searching throughout the tree. So only for the traversal we are going to do that. So in the worst case, we say the time complexity may be of the order of ON. Now, in order to handle this property, so that you can say we are just trying to make an effort. So can we do something that with the help of which, because the trees which are generated, see, trees are generated randomly, so whatever data we have received, so it may be you can say it may be a skew tree, it may be a left skew tree, or it may be a right skew tree, right? So depending upon the input values that we have received. So in order to reduce that particular time, you can say, in order to improve the worst case time complexity of the binary search trees, so what can be done? So there is an algorithm which